Okay, before we maybe open it up completely, I'm going to take my opportunity as chair to try and clarify a question. So there's two questions here, I suppose. One is small wind a technology that has potential and should be and could be playing a role in energy access in developing countries? Are we all agreed on this panel that small wind does have a role if it's in the right place and there's an adequate wind resource and you know, in a way, as a manufacturer of small wind turbines, you don't think necessarily that small wind has a role to play, please?
We are quite close to finishing a energy conversion device selection tool, which we will put up for free on the web. We're running it in beta at the moment. We've been developing it and we have paid for it ourselves with no support from any charity or anybody. It covers the world. We'll put it up on the web, and from a pull-down menu you can dial in your local wind resource. One day if somebody gives us a bunch of money, we can pull up a world wind map. You can dial in your local solar resource. In fact, that's calculated. What we also have in there is we have pre-cooked the variability of those resources. Let me just take you through that for a moment and you'll see where I'm going. Because making decisions is the most important thing we all do as humans. And we're trying to give people the information to make decisions. In Hong Kong, you can have an annual average wind speed of about 5 meters per second, and you've got solar because you're pretty close to the equator. In Britain, we got a mean annual wind speed of about 5 meters per second, and we don't have so much solar. If you were to choose the wind turbine, the right wind turbine to meet a 100-watt load there, and the right amount of battery and the right amount of solar, you don't choose the same size of wind turbine or battery size. The reason is that in Hong Kong, pretty much the wind blows every day, whereas in the UK, the wind comes through in about a 5 to 7 day cycle. In Peru, it's different again because we're driven by different atmospherics. So you would size the battery bank, this is for off-grid use, you'd size the battery bank in the UK to be a larger battery bank than the one in Hong Kong, because you have to last pretty much between your 5-day wind pulses coming off the weather fronts coming through. Now, every part of the world has a different variability signature, and you can't sit there as an unsophisticated consumer and be expected to make those complicated trade-offs. So we're putting that information into an accessible package on the web. When you then dial in your latitude and longitude, it does all the solar calculations, you pull down your local variability index, and you'll be able to see what is the right technology for you. And many, many times it is not wind, even if you have wind. Many, many times the right technology is not a wind turbine.
Not always, presumably, or you'd be out of business.
Even if you have a good wind resource, the closer, in general terms, the closer you are to the equator, the better off you are with solar. And the real issue for the industry is we've got to drive down our cost per kilowatt hour at least as fast as the solar industry is driving down its cost per kilowatt hour. In addition to that, the wind industry needs to drive down costs of storage, because solar is pretty much a daily cycle towards the equator, whereas wind is not normally a daily cycle. So we have to invest in storage in a way the solar guys don't. Where the wind guys get the advantage is when you get towards the poles, solar becomes pretty useless. And that's when wind has an advantage. So even when you have wind, solar is increasingly winning because wind is losing the economics game.
Anyone want to come back on that? I mean, obviously, the next point really is what's driving the cost, and what is the minimum cost, and is there a minimum cost? And obviously the Hugh Piggott kind of school of thought is that you can reduce the costs by making it locally to the point where it's not about competing with solar. You can't make a solar panel, but you can in principle, make a wind turbine. This is the question we're going to come on to in terms of the best way of making it. But I'm not clear if we have consensus on wind, the role of wind in developing countries. Is there anyone else wants to say anything about that? When does it work, or when could it work?
I agree with most of the points, but in some cases, for example, you have wind resource very predictable. In Peru, we have along the coast, we have from 9 to 12 hours a day of wind every day, and you have very poor people along. And in that case, it's really very good resource. Solar is not a very good. The atmosphere is not so good in that place. So in that case, wind is very much winning the case. Now, in terms of costs, yes, wind is relatively expensive, and especially if in the poor countries, if you import from developed countries where the cost could be 5-6 times more expensive than that built in the country, then that's very difficult. And I agree with the lot of maintenance, the care that needs the wind turbine. As we all said, it's not a very simple technology. Perhaps the trick is in how to improve that technology for the poor, how to make it more reliable. And that's where practical action is focusing now, especially in Peru. I just come having some discussion with manufacturers there. The point of the investment that was made about 5 million in developed country, 500,000 in developing country. That's probably true, and it's difficult to set a proper company in a developing country. I mean, especially if you look at the market, people tend to follow those typical patterns. If it is Western, that is good. Then for a local company to get the market is very difficult, and invest 500,000 to really produce good qualities is difficult. So I think there are many adverse points which make more difficult the technology in those cases. But I think it's a challenge that it's possible to overcome.
Just to come back on David as well, to look at it from a different perspective rather than global markets and reducing the cost of kilowatt hour. If you're in a development situation where there's a community that need, as Theo is saying, 2 to 3 kilowatt hours per month, can you afford to import solar panels? No. But is there a local supplier of wood? Yes. Is there metal about? Yes. Is there copper about? Yes. Is it possible with a bit of knowledge to build something that can produce the 2 to 3 kilowatt hours per month? Yes, then it's definitely appropriate, and it's definitely possible, and it's proven that it can and will work. So,
please go ahead.
I think that there's a fundamental sort of choice, really, philosophically, technologically, which I still haven't got my head around. I'd be very interested to know what people think. On the one hand, you've got manufactured products, tightly made, in a factory, high quality, good tolerances, work well, robust, reliable. On the other hand, you've got making stuff, teaching people how to make stuff, using local materials, and that approach. And I see those as quite extreme opposites, and I don't really know how we make that choice. And I can see benefits on both sides. If you look wider than just efficiency and pence per kilowatt hour or whatever, I mean, if you look at how do we employ people, how do we involve people, how do we educate people, there's benefits on both sides. And I'd just be really interested to know what you think, because as an engineer, working in a UK university, I'd always tend towards the one on my left hand, and if I'm doing projects with students, one of the problems with doing appropriate technology projects is that all my colleagues kind of go, that looks like garage engineering, it looks terrible, it's not going to work. And okay, you might disagree, but that's an issue because I'm trying to say, well, this is worth doing, and they're going, well, it's rubbish. So there's a kind of issue there which I'd really like to discuss a bit further.
Yeah, so I'm going to open it up to the audience in just a second. But I think one of the interesting points I'd like to get into is, where is the line? I mean, often you're using, see, with the hydro turbine even, you're still buying a generator or buying an AC motor, which is manufactured in volume, or even the magnets you're talking about. Those are manufactured. So there's always a bit that you're generally bringing in that's been manufactured, but then you're also making some of it. And one of the reasons for this debate is to think about the wind turbine aspect. How important is it? The generator is probably manufactured. Is it important the whole turbine is manufactured? Or is it important that the pole and the installation is done externally? And also there's at various points when the jobs come in, isn't there? Like the jobs in making the turbine, but also the jobs in maintaining it, or the jobs in providing spares, and so on. So these are some of the things I think we hopefully will get to.
There's an extremely important point that we haven't covered so far. A 5 or 6 kilowatt turbine is big enough to kill you.
So the safety aspect. Absolutely. Okay, can we get any views then from the audience? Yeah, does anyone get any experience of wind or any... There's kind of quite a clear debate emerging here, I think. What do people think about it?